Good morning, everyone. My name is Eric Romo. I am the DS21 tutor here at Fresno City College, and today we'll be talking about compounding interest for a lump sum. So if we take a look at my screen right now, you'll notice that I have the formula for calculating the future value of a lump sum with compounded interest. Now you'll notice if you watch one of my previous videos, this formula is very different than the future value of a lump sum for simple interest. And it's different because we'll notice we have an I, and then we have an exponent n right here. So I wanted to kind of talk about that because if we graph both of those equations, I'm going to write this really quickly down here. This is simple interest on the bottom. P1 plus r times t. Okay. If I were to graph both of these functions, the simple interest would look like a straight line versus this one, which is actually to the exponent, which will follow an exponential curve. Okay. Make that one right there, there. This is my x, this is my y. And we know that x is actually our time period. So one of the things I also want to talk about is that right here, this I is actually equal to r over m, or if we look over here, is your rate of interest divided by m, which is your compounding periods. And n is equal to m times t, which is your compounding periods multiplied by the time period. So what ends up happening is that we have over here compounding periods, annual, semi-annual, quarterly, monthly, and daily, with annual being 1, semi-annual 2, quarterly is 4, monthly is 12, and daily is 365. So if you read a problem, an example problem that says a principal value of $5,000 was compounded interest semi-annually at 8% for 3 years. So when you hear that compounded semi-annually, you'll go over here to your little chart and be like, okay, well, I know that semi-annual means there's 2 periods because there's 2 halves of a year. So I'm going to use this value right here. So let's go ahead and put this into practice. I have a principal value of $5,000. I've got a, let's see, rate of interest at 8%. I have a compounding periods of 2 because it's semi-annual, and t of time periods, which is, I'll say, 5 years. So really what you're going to do is you're just going to plug them in to your equation. And if I want to write out the expanded form of this, if I is equal to rm and n is equal to m times t, then I can place in here by substitution r over m and n times t. So I'm going to go ahead and plug all these in. A is equal to 5,000, 1 plus 0.08. Notice that I have to convert my percentage into a decimal. We cannot calculate with percentages in finance. We have to use the decimal form. Divided by m, which is your compounding periods, is semi-annual. And to the m times t. So m multiplied by t. 2 times 5. So let's go ahead and simplify for a second. So you want to do your parentheses first. Do the parentheses, so I'm going to do this one, which is division. I'm following PEMDAS, okay? I got to do this time, this I part first. So I'm going to do 0.08 divided by 2, which is 0.04. Okay. And then this up here is going to become 10. 2 times 5. So let's keep going with PEMDAS. 1.04, 1 plus 0.04 to the 10th power. Okay. Now I need to do this one first. This is to the power, so I need to get out my calculator. One 1.04 to the 10th power. Okay, I get this really long decimal. Now, remember in finance, we never ever want to round anything. So I'm going to keep it like this, and I'm going to multiply my 5,000 by this number. Multiplied by 5,000. Okay, so my compound future amount is going to be this value, 7,401 and 22 cents. Let's go ahead and write that in. 7,401 and 22 cents. Now, I rounded there because that's the very end of our finance equation. All right, and that's all there is to it.